Hello and welcome to the review of chapter 2, which is quadratics, and we are going to do the exam questions. And the first exam question is here. So f of x is x squared plus 3x minus 5, and g of x is 4x plus k, where k is a constant. Given that f of 3 equals g of 3, find the value of k. So basically what happens here is that when we input the function of f3 to f of x, then everything gets replaced with 3 instead of x. So f of 3 equal g of 3 will basically replace the x with a number 3 in both of f and g. So here 3 squared plus 3 times 3 minus 5 will equal to g of 3, which is 4 times 3 plus k. So now 9 plus 9 minus 5 minus 12 will equal to k, because here 3 squared is 9, 3 times 3 is 9, minus 5 is minus 5, and we bring minus 12 to this side because we get plus 12 from the result of 4 times 3, so I just brought it to the other side in one go, and now we can solve it. So 18 minus 17 equals to k, 1 equals to k, so k equals 1. Now for the part B, find the values of x for which f of x equals gx. So now f of x, x squared plus 3x minus 5 will equal to our g of x, which is 4x plus k. But because k is 1, now we put plus 1 instead of plus k. So now we just put the values to the other side. So here would be minus 4x and minus 1. So x squared minus x minus 6 will equal to 0. We solve it using factorization. So here is negative 1, negative 6. We write out our factors, so 1, 6, 2, 3. We then check which one of those will suit the following, and it will be minus 3 plus 2. So x minus 3 and x plus 2 will equal to 0. So x equals to negative 3 and x equals to negative 2. Now we got the next question. So in here we got exactly one solution, meaning that b squared minus 4ac will be equal to 0. And now we just plug in the coefficients. So a equals 5, b equals minus 2, and c equals k. So minus 2 squared minus 4 times 5 times k will equal to 0, and 4 negative 20k will equal to 0. So 20k will equal to 4, and k equals to 4 over 20, which is 1 over 5. So k equals to 1 over 5. Now for the question number 7, given that for all values of x, 3x squared plus 12x plus 5 equals to the following, which looks like completing the square. A, find the values of p, q, and r. So this form looks like a completed square, so we have to complete the square. And basically the formula for it was, so now what happens, we use this formula, we plug in the coefficients, and we get the following. And so we plug in the numbers, and we get 3 bracket x plus 2 bracket squared minus 7. And so we can determine the values. So p equals 3, q equals to 2, and r is equal to negative 7. Now the part B, hence solve the equation 3x squared plus 12x plus 5. So we take our completed square we equate it to 0, and now we plus 7 on both sides to get this. We divide both sides by 3 to get this. We square root both sides, and then we minus 2 from both sides. So here we have solved the equation for the following function. Now for question 8, we have the following function of f, where x is a set of real numbers, and we have to write f of x in the form of the products, where a and b are real constants. So here we can see that this relates to this. Now when we see that and when we spot that, we can use the y to turn y into something, to turn the 2 to the power of x to equal to y, to make it solvable. So 2x minus 20 to power x plus 64 can be rewritten as this. Now let y equal to 2 power x, so y squared minus 20y plus 64. Now using factorization we can solve this. So that's minus 16 and minus 4, so that is y minus 16 and y minus 4, but 2 power x is y, so 2 power x negative 16 and 2 power x negative 4. So that's what we wanted, and a is 16 and b is 4. Now hence find the two roots of f of x. So using our answer to part A, because it says hence, so we have to use the part A, we are going to solve this. So 2 power of x minus 16 equating to 0, and 2 power x minus 4 equating to 0, so that is 2 power x equals to 16 and 2 power x equals to 4. Now here by inspection we see that x is equal to 4 and x is equal to 2. Now we got the modeling question, and in here a diver launches herself off a springboard. The height of the divers in meters above the pool t seconds after launch can be modeled by the following equation. So we have to visualize what is going on. So the diver launches herself off a springboard, so there'll be a springboard here, there'll be water here, so here will be the diver. So here in part A, so when t equals to 0, ht equals 10, so the answer is 10 meters. Now for the question B, use the model to find the time at which the diver hits the water. So that will be when the height of a springboard is 0. So basically here, the distance from here to here is 10 meters, and once she hits the ground, so she will dive like this, that's when the height will be 0. So ht equals to 0, so when ht is 0, 0 equals to 5t minus 10t squared plus 10. And now we can bring everything to the left hand side so that we get the following, and so we can solve it using a quadratic equation. So t and t using a calculator so that it's quicker, we get 1 plus minus 17 over 4. So that means that time is equal to 1.2807 seconds, or time equals to negative 0.78 seconds. We round to 3 significant figures, which is 1.28. Negative seconds cannot be true because we cannot go back in time, so that is not true. And this is true. So use the model to find the time at which the diver hits the water. Diver hits the water at 1.28 seconds. So now the C, rearrange ht into the form of completing the square and give the values of the constants a and b and c. So we complete the square simply, so 5t minus 10t squared plus 10 will equal to ht. Now the formula for completing the square is a, so we just plug in the numbers to the formula to get, so we get the following when we plug in the numbers and doing the calculations on a calculator. And here we get a, which is 10.625, we get b, which is 10, and we get c, which is 0.25. Now the part D, using your answer to part C or otherwise, find the maximum height of the diver and the time at which this maximum height is reached. So we have to find the maximum height of the diver and the time at which this maximum height is reached. So the maximum height of the diver is, so basically this is when we have the maximum height reached, so this is the turning point, and we can work out the turning point by looking at our completing the square equation. So here we have 0.25 and 10.625 coordinates, like so, because to find the turning point you have to invert the first one in the bracket and then you have to keep the outside. So here we flip 1 over 4 and we keep the 10.625. So the maximum height is 10.625 meters at 0.25 seconds. Now for question 12, we have f of x as following, where k is a real constant, and a, we have to find the discriminant of f of x in terms of k. So here we have the coefficients for k, we have 4k plus 2 and 1. So to find the discriminant we have to do the b squared minus 4ac, which equals to 4k plus 2 squared minus 4ac. And now we just work this out, so 4k plus 2 and 4k plus 2 multiplied together is 16k squared plus 16k plus 4 minus 16k is going to be 16k squared plus 4. For part B, by simplifying your answer to part A or otherwise, prove that f of x has two distinct real roots for all non-zero values of k. So for part B, we can see that anything squared is always positive or equal to 0. Now, k squared is always positive or equal to 0. So k squared is greater than or equal to 0. So that means that 16k squared plus 4 will be greater than 0, because if the smallest value of k squared is 0, then we have 4 which is greater than 0. And if it's greater than 0, then two distinct real roots. Now part C. Explain why f of x cannot have two distinct real roots when k is equal to 0. Now, here we have concluded with the discriminant that if k squared is 0, so if k is 0, then 4 is greater than 0, and therefore we have two real roots. But when k equals 0 for our f of x, it becomes 2x plus 1, which is an only one root, so linear function gives one real root and not two distinct real roots. So no distinct real roots when k is equal to 0. Now we have the question 13, where we can see again the relationship between the x power 8 and x power 4. We can rewrite this as x power 4 to the power of 2 minus 17 x to the power of 4 plus 16 equals to 0. We're going to let y equal to x power 4, so that y squared minus 17y plus 16 is equal to 0. We are going to factorize it to get minus 16 minus 1, so y minus 16 y minus 1 equal to 0, but y is equal to x power 4, so x power 4 minus 16 and x power 4 minus 1. Now we make both of those equal to 0. And we have x power 4 is equal to 16 and x power 4 is equal to 1. So here x equals 1 and then here x equals 2. We can also have x equals to negative 2 and x equals to negative 1. So usually we have 4 roots when we have power of 4. Now this is the last question of the review exercise, where Lynn is selling cushions as part of the enterprise project. On her first attempt, she sold 80 cushions at the cost of £15 each. So she did 80 times 15, which is £1,200, and she hopes to sell more cushions next time. Her advisor suggests that she can expect to sell 10 more cushions for every pound that she lowers the price. The number of cushions sold C can be modeled by the equation C equals 230 minus HP, where P is the price of the cushion and H is a constant. Determine the value of H. We have an information that she sold 80 cushions, so 80 equals to 230 minus H, and P is the price, which is 15, so here 80 equals to 230 minus 15H, and 15H equals to 230 minus 80, and 15H is equal to 150, so H equals to 10. So now in the context we have worked out the value of H, so we can use the value of H to work out the next stages of the question. So here we have our model as C equals to 130 minus 10P. Now, to model her total revenue, R, Lynn multiplies the number of cushions sold by the price of each cushion. She writes this as R equals to P 230 minus HP. So she writes this in the form R equals to P 230 minus 10P. And for part B, we have to rearrange the R into the form of A minus B, basically as complete the square, where A and B and C are constants to be found. So R equals to 230P minus 10P power 2. So here A is minus 10, B is 230, and C is 0. And we have to use our complete the square formula, which is the following. We plug in the coefficients into the formula, so we got it into this form, and A is going to be equal to 1322.50, B is going to be negative 10, or actually 10, C is going to be 23/2, which is 11.5. So now for part C, using your answer to part B or otherwise, show that Lynn can increase her revenue by £122.50 through lowering her prices, and state the optimal selling price of a cushion. Here, using our graph, that is negative, so we probably have a graph somewhere like this. This is not accurate, but here we got our maximum, and the maximum occurs when we have negative A and B coordinate for our values in completed square. So instead of having negative 23/2, we have 23/2. So that's 1011.5 and 1322.50. Here is the price, and here is number of cushions. I mean price for, so that's price overall, and that's price for cushions. So increase in revenue is 1322.50 minus 1200, which is 122 and 50 pence. So that is correct. And the price that we need to also state we need to show that Lynn can increase her revenue by £122.50 and state the optimum selling price of a cushion. So optimum selling price of a cushion is £11.50. That is where she gets the most revenue, and that's what she should have on her price. So I hope this video helped you and that you'll be able to understand quadratics and that you'll be ready for the next chapter, which is equations and inequalities.